Hi friends, welcome to the Unit 3 Day 5 notes. Now we're going to jump into horizontal oblique slant asymptotes. In this case, we have different scenarios. When you have a horizontal asymptote, you have one of three scenarios. It's always one of these particular three scenarios. So it will always fit one of these scenarios. If the denominator has a greater degree than the numerator, then the horizontal asymptote is always at y equals 0. So an example of this, if you have y equals x plus 3 over x squared minus 4, then in that case, what's happening is the numerator degree is less than the degree of the denominator, so the denominator is greater, then your horizontal asymptote is always at y equals 0. In this case, you get really close to y equals 0. You get really close to have that y value, but you will never reach it. So that's what's happening for this particular scenario. If the numerator and the denominator have the same degree, then the horizontal asymptote is the simplified coefficients of the numerator and the denominator's highest degree terms. So an example of this, if I have y equals 2x squared plus 4x minus 5 over 6x squared minus 7x plus 2, then what you do is you take the coefficients of both the numerator and the denominator, and then you just simplify them. So this 2/6 here, I simplify that, and I get y equals 1/3 after I simplify that. So this is my, again, this is my horizontal asymptote. So here we have a horizontal asymptote. And then here, we also have a horizontal asymptote. If the degree of the numerator is greater than the degree of the denominator, then we have what's called an oblique, or sometimes you'll see it referred to as a slant asymptote. This is nonlinear. This asymptote is found by dividing the numerator by the denominator, and then you disregard the remainder. So we set the quotient equal to y for the equation of this particular asymptote. Example of this, if I have y equals x squared plus x plus 1 over x plus 1. So note the degree of the numerator is greater than the degree of the denominator. I'm just going to do synthetic division quickly to show. So here I have negative 1 dividing by x plus 1, so negative 1. My coefficients are 1, 1, and 1. Bring down the 1, negative 1, 0, 0, remainder is 1. We disregard the remainder for writing this particular equation of the asymptote. So this is a slant asymptote. This is a slant asymptote or an oblique asymptote, and it's y equals 1x plus 0. So we would just write it as y equals x. Notice that this particular instance for this particular one, because this is a slant asymptote, this one produced an equation of a line where these two, a line with an x value. So we have essentially a slant. And then these two are vertical lines. So this is going to be a line that has a slope. This one is going to be just vertical lines. So asking you to find the asymptotes for each of these rational functions, what I'm really looking for is first, which category does it fall into? So let's figure out which category they fall into first. For number 3, the degree of the numerator is 1. Remember, we find the degree by looking at the variable and the power. So this degree is 1 over degree 2. So the degree of the denominator is greater than the degree of the numerator. So this is this case here. So we have this scenario so that the horizontal asymptote is going to be y equals 0. For this particular one. However, it says find all asymptotes, so I also need to find out the vertical asymptotes. Remember, the vertical asymptotes we find by setting the denominator equal to 0. We factor the denominator, the numerator, see if we have anything that can factor out. So in this particular case, if I factor out my denominator, so that's going to give me x plus 3 and x minus 2. So if I have x plus 3 and x minus 2, then that means I can cancel out this one and this one. because we have a hole, so now I know I have a hole, and my hole, remember we plug in, we set this part equal to 0, so x minus 2 equal to 0, add 2, x equals 2. So now I'm going to plug in that 2 back in for x in my simplified one. So I have y equals 1 over 2 plus 3. So y equals 1/5. So this is going to have I have a horizontal asymptote at y equals 0. Looks like I have a hole at 2, 1/5, and then a vertical asymptote at x equals -3. So horizontal asymptote at y equals 0, vertical asymptote at x equals -3, and then a hole at 2, 1/5. 1/5 is 0.2, so that would be sufficient as well. Number 4. So what we have here looks like I can factor. Looks like I'm in standard form. That's good. Okay. So now I just check the leading coefficients. The degrees. The degrees are the same. So this is scenario B from here. So now I just simplify the leading coefficients, and that's going to be my horizontal asymptote. So in this case, I have a horizontal asymptote. If I simplify 4 divided by 1, so that's going to just give me 4. So I have a horizontal asymptote at y equals 4. Set my denominator equal to 0 and then solve. So x plus 1 equals 0. Subtract 1 on both sides and I get x equals -1. So this has a vertical asymptote at x equals -1. Number 5 is written incorrectly. I just caught that. Y equals, or f of x equals, or g of x equals. So here we have the degree of the numerator is greater than the degree of the denominator. So this is like example C from up here. So in this case, this scenario, we need to divide out by that. So I'm going to go ahead and do that here off to the side. So I have 1 synthetic division, 1x squared, 1, and then 0. Bring down 1, 1, 2, and then I disregard my remainder. So my horizontal asymptote, or in this case my slant asymptote, for this particular problem, is going to be y equals x plus 2. My denominator equal to 0, and then solve. So this gives me a vertical asymptote at x equals 1. And then for number 6, the degree of the numerator is greater than the degree of the denominator. So again, this is going to also be a scenario where I need to do synthetic division. This is going to be with -2, x cubed, 1, no x squared, no linear term, -8. Okay. 1, -2, -2, that's 4, 4, -8, -16. Yeah, disregard that. So then my horizontal asymptote, or in this case my slant asymptote, is going to be y equals x squared minus 2x plus 4. My vertical asymptote, when I set the denominator equal to 0. And then this is going to be x plus 2 equals 0, minus 2 minus 2, so I get x equals -2. So my vertical asymptote is x equals -2. Checking this. X cubed minus 8 is a perfect cubes. However, when I simplify it, I get x minus 2, and then x squared plus 2x plus 4. Didn't catch that, but fortunately, even though I didn't catch it, it still doesn't reduce. If this was x minus 2, then that would change that, and then I would have a hole instead of a vertical asymptote. Next video, we're going to jump into why we even find these, and then our end result, our end goal here is to actually graph them. So I'll see you then.